Okay, to solve this linear equation, the first thing we're going to do is distribute the negative 4. That gives us negative 8x plus 24 plus 8x equal to 5x plus 24 plus x. Now we're going to combine like terms. Negative 8x plus 8x is 0, so those two drop out. Over here on this side, positive 5x plus x is 6x. And if we bring down the plus 24 on both sides. Okay, now we're going to subtract 24 from both sides. That leaves us with 0 equal to 6x. Divide by 6. So 0 is equal to x. All right, to solve a linear equation with fractions, we want to clear out the denominator. So to find a common denominator, we're going to multiply those two together. 15 times 9. And we're going to use that product on both sides of the equation to cancel out the denominator. So I want to get rid of 15. So 15 divided by 15 is 1. That leaves us with the 9. 9 times 2x plus 5. Okay, on the right side, we want to get rid of the 9. So 9 divided by 9 is 1. And that leaves us with the 15, so 15x plus 30. Okay, now I'm going to distribute the 9, so that gives me 18x plus 45 equal to 15x plus 30. Now I'm going to take the 15x over to the left. That leaves me with 3x plus the 45 equals 30. And finally, I'm going to take the 45 over to the right side by subtracting. That leaves me with 3x equal to negative 15. And then the last step, we're going to divide by 3 on both sides. So x is equal to negative 5. All right, to solve this quadratic equation, I'm going to start off by setting it equal to 0. So I need to add 7 to both sides. X squared minus 6x plus 7 equals 0. What I want to try first is to see if I can factor it. X times x is x squared, and the factors of 7 are 1 and 7. So if I do x minus 7, x plus 1, I'm trying to get the negative 6x in the middle, so negative 7x plus 1x does give me the negative 6x. However, if I take negative 7 times positive 1, I do not get positive 7. I get negative 7. Okay, so that's not going to work. I'm going to go ahead and solve this quadratic by using the quadratic formula. Which means I need to list out my A, B, and C. Okay, A is 1, B is negative 6, and C is positive 7. Okay, the quadratic formula, x is equal to negative b plus or minus the square root of b squared minus 4 times a times c divided by 2 times a. Okay, so what I want to do is replace a, b, and c. So that leaves me with x is equal to negative b, and since b is negative 6, plus or minus the square root of negative 6 squared minus 4 times 1 times 7 divided by 2 times 1. Now what I'm going to do is I'm going to take my discriminant and I'm going to evaluate that to see what my answer is supposed to look like, to give me a heads up. Okay, so over here I've got negative 6 squared, which is 36, minus 4 times 1 times 7, which is 28. 36 minus 28 is 8. Okay, so if I look at it, 8 is not negative, so I know that I'm not going to have a complex answer. And also 8 is not a perfect square, so that means that I'm going to have an irrational answer. Okay, so I'm going to go back over here to my problem. X is equal to positive 6 plus or minus the square root of 8 divided by 2. Before I can move on, I'm going to have to simplify this radical. And I'm going to do that using the cake method. 8 divided by 2 is 4. 4 divided by 2 is 2. Take the 2 that pair up. 2 square root 2. Okay, so now I have x is equal to 6 plus or minus 2 square root of 2 over 2. Right here's the part where I want to separate this into two fractions. X is equal to 6 divided by 2 plus or minus 2 square root of 2 over 2. And then finally, if I go ahead and reduce, 6 divided by 2 is going to give me 3. And then 2 divided by 2 is 1. So x is equal to 3 plus or minus the square root of 2. Okay, the final example here is a rational equation, and the first goal is to get rid of the denominators by finding a common denominator. Okay, if I factor this denominator, I'm going to get x times x plus 1. Okay, and if I take these two denominators and multiply them together, I'm going to get the same thing. So my common denominator is x times x plus 1. So x times x plus 1 multiplied on both sides of the equation will clear out the denominators. Okay, so that's going to give me x times x plus 1 times 4x plus 3 over x plus 1 plus x times x plus 1 times 2 over x equal to x times x plus 1 times 1 over x times x plus 1. So what I did, let's recall what I did. I took the common denominator and distributed it across the whole equation. Usually this part can be done in your head, but it's a good idea to have this written out so that you can reduce it. So x plus 1 divided by x plus 1 is 1, so that leaves me with x times 4x plus 3. And then x divided by x is 1, so that leaves me with 2 times x plus 1. And then x times x plus 1 divided by x times x plus 1 cancels out, and I have 1. Now, doing the distributive property, 4x squared plus 3x plus 2x plus 2 is equal to 1. We're going to go ahead and combine like terms. That's going to leave me with 4x squared plus 5x plus 2 equal to 1. And since this is a quadratic, I need to set my equation equal to 0. So I'm going to subtract 1 on both sides. So that's going to leave me with 4x squared plus 5x plus 1 equal to 0. Okay, since we do have a quadratic equation, we want to solve it by using a quadratic method. It's good to try to do the factoring first if you can. So taking that first term, 4x times x gives me 4x squared. The last term is 1 times 1. And just to check myself, 1x plus 4x is going to equal to 5x. So the factoring works in this case. So we're going to stick with that. Set each factor equal to 0. And solve for x. 4x equals negative 1, or x is equal to negative 1 divided by 4. Or over here, x is equal to negative 1. Now, this is the really, really important part. We're going to need to check our answer to see if it works in a rational equation. Okay, let's go back to the beginning. X plus 1. If x is negative 1, then this denominator will turn to 0. So the solution that we got for x equals negative 1 is going to cause 0 in the denominator, so that's not going to be a solution. However, if we substitute negative 1/4 in, negative 1/4 plus 1 is equal to 3/4. And that's okay to have in the denominator. And it's also okay to have negative 1/4 here. Okay? So that makes our solution to this rational equation x equal negative 1/4.